In the name of Allah, the most gracious and the most merciful. Assalamu alaikum, dear students. I hope you all will be fine. Today is 25th April 2020 and the day is Saturday. This lecture is for grade 7 and the subject is General Science. So students, I want you to open your General Science book and go to page 117. I hope you will be on page 117. In the front of you, there is a topic in the name of measuring temperature. So this is our topic for today, and we will learn about the technique of measuring temperature by different thermometers. Okay, so students, look to the first paragraph. What it says physical properties of a material that changes steadily with temperature can be used to measure temperature. Different types of thermometers make use of different physical properties to measure temperature as shown in the following. Now, what does it mean? It means to say that when a change occurs in a material, these changes are used for detecting temperature. Now, change to a material could be of two types. One change is called physical change and the other change is called chemical change. So the physical change of a material, it would be like that you have a whiteboard, okay, and you cut that whiteboard into two pieces, but the whiteboard it still remains the whiteboard. Those two parts you have cutted are still the whiteboard. There is no change, okay, it does not have changed their shape. But if you burn that whiteboard, then it is not a whiteboard now, it is ashes. The shape of that material is now changed. So this is called the chemical change. So for detecting the temperature, we are using the change in physical property. We are using this as a tool for detecting the temperature. Okay, so when a physical change or where there is a change occur in the physical property of a material, we with the help of that we will detect the temperature. For example, those physical property, they may be in the form of some material. For example, if liquid, they will be expanding. If gases, they will be expanding when the temperature is high, but when temperature is cool down, then they will contract. Okay, so the gas and the liquid is not changing its shape, it is still that gas and liquid, but the physical property is changing, and with the help of that change we can detect a temperature. Okay, because we have read about the bimetallic step where there the brass and the iron, when there is a temperature that is very low, so the brass, it expand, but the copper it contracted. Okay, sorry, the brass contract more but the copper contract little, that's why they bend upward, but at room temperature they are straight. Okay, so we will also use these physical properties because every thermometer have their own thermometric property. Thermometric property is that property at which the temperature at which the thermometer indicate a temperature. Okay, so every thermometer, it is working on its own on a separate physical property change in the material. Okay, in most of the cases you will see the clinical thermometer, they are using the mercury. So that mercury is a material, and when they are expanding and when they are cooling down, they are showing you the temperature. Okay, I will say that different types of thermometer make use of different physical properties in measure as shown in the following. Okay, I just explained that how these thermometer, we have not just only one type of thermometer, but we have many type of thermometer, and we are using it and those thermometer are using different property to measure the temperature. So the first one example of the thermometer, we have liquid in glass thermometer. So student, look to the book. It says in liquid in glass thermometer, the volume of a fixed mass of liquid change steadily with temperature. We have already read this example in the class, but let's look to it again. Liquid and glass thermometer, I will just show you the diagram also, but in the narrow tube, or in the narrow capillary of that thermometer, there is a fixed mass of liquid. That liquid may be mercury, or there may be alcohol. So there is just only a fixed mass. There is no addition and no removing from that liquid. Okay, it is in a fixed limit, and when the temperature is increasing and decreasing, so that liquid is expanding and contracting with that temperature. The second is constant volume gauge thermometer. In a constant volume gauge thermometer, the pressure of a fixed mass of gas at constant volume varies uniformly with changes in temperature. So in liquid in glass thermometer, they have put a fixed mass of liquid, and in constant volume gas thermometer, they have put a fixed mass of gas in that thermometer. Let's look to this example. So in figure A, in your right hand side, this one is a liquid in glass thermometer. Okay, so in liquid and glass thermometer, you have seen that they have given us a fixed volume of liquid. Okay, this is a fixed volume of liquid here. So this fixed volume of liquid, it is expanding and contracting when the temperature is changing. So if the temperature high, it expand more, and it will show you the temperature. Okay, here the reading will show you the temperature, that what is the temperature currently. Okay, and when it cools down, then it will contract and it will go down to that bulb. Okay, so it's just like simple, like as mercury. Okay, but the liquid may be mercury or alcohol are mostly colorless, so that's why they add red color to it. That's why you see this in the red color. Now let's move to the constant volume gas thermometer. In constant volume gas thermometer, the shape of this thermometer is like this. There is this closed flask, okay, and here we have a gauge. Okay, so in the opening of this flask is here, it is always sealed. Okay, it is sealed. So it means to say that there would be no entrance of gas into this round flask, and there would be no gas coming out of from this round flask. Okay, so if you look to this example, if you put that flask and you have a beaker in water, okay, there is water, and you put that round flask and with the gauge in that water, and you start heating. Okay, here is our heating. You start heating this water. What will happen? The heat will transfer to this round bottle. Okay, and in the round bottle, the gas molecule will start expanding. Okay, and when it start expanding, it will increase the pressure. Those molecules will collide with one another, and they will increase the pressure. Okay, so as a result, here in this gauge, you will see the pressure, that how the pressure is rising. Okay, so if you look to the second diagram, here the heat is on medium. So look, the gauge, it was first at 0 here, it was at 0 here. Now it has reached to some in the middle of that gauge. Okay, now after you increase the temperature more, then look to this gauge, the molecule, and look to the level of the water also. It has also risen up. Okay, and the pressure is also increased. Now what is the relation with the pressure of the heat? Well, in a closed container, when it is closed, okay, look to this bottle, it is closed, it is sealed here. In a closed container, how much air molecule or air is there? It is directly proportional to heat. What it means, that the heat in this kind of closed container, the heat, it directly affect the pressure. It means that if heat directly proportional to pressure, okay, so if the heat is rising, if the temperature is rising, so the pressure will also rise. Okay, so that's why when you put that in a liquid, in this round flask, and you have a gauge over there, so and there is a heat going on, and when the temperature of that water, of that liquid, is rising, so the molecule inside that round flask will expand, and it will create the pressure, and the pressure gauge will tell you how much pressure it is now. So how does it will help you in temperature? Because the pressure, if the temperature reached to 80 degrees Celsius, the pressure would be different if the temperature reached to 100 degrees Celsius. Okay, so just by looking to the pressure, then you will tell that, oh, this pressure could be at this temperature. It means to say that at this pressure, the liquid what you have will have now the temperature of 80 degrees Celsius, 100 degrees Celsius. Okay, so these kind of thermometer, they are mostly used in industries, okay, where they are making something liquid, so they check the pressure and the temperature like this. Okay, now let's go to the next example. Now the next example, or the next thermometer they had given us, is the bimetallic thermometer. In a bimetallic thermometer, the uneven expansion and contraction of bimetallic strip changes steadily with temperature. Okay, so in this thermometer they are using the principle of bimetallic strip, which we have also studied in many other appliances also, okay, in many other materials or things also. The next is thermocouple thermometer. In a thermocouple thermometer, the amount of electric current flowing in the wire changes uniformly with changes in temperature. So in this thermometer they are using electric current. With the help of electric current, this thermometer will tell you the temperature. In the bimetallic strip, with the help of bimetallic strip, it will tell you the temperature. Okay, now let's look to this example. If you look to the first one diagram, it is the diagram of bimetallic strip. Okay, so in bimetallic strip, if you remember, bimetallic strip, it is made from brass and iron. So okay, so if you if the temperature is cooled down, okay, so the brass contracted and the brass expand and the iron contracted. Okay, and when the temperature is high, then the brass expand and the copper contracted. So if you look to the this diagram, okay, here we have this bimetallic strip, okay, and in reality and in actually they are placed in the thermometer just like this. Okay, they are in this narrow tube. Okay, so look to this. When the temperature was 0 here, when the temperature was 0, okay, or if the temperature was normal, So at room temperature, we know that bimetallic strip is straight. So if they are straight, it means that there is no change in the temperature now. But once the temperature, if you if you look to here, the temperature is cold. Here the temperature is cold. So in this case, what happened here? In this case, the brass is contracted and the iron is expanded. So they have made, or they have pulled a force on this pointer. Okay, let me change the color. So when the brass contracted and the iron expand, they have made a force on this pointer, and this pointer is toward 0°C. Okay, but after they have put this thermometer in a hot object or in hot liquid, so at hot temperature, what happened here, the brass is expanded and the iron is contracted, so which had as a result this pointer is moved toward that much temperature. Okay, first it was at 0, now it is maybe on 30 or 40°C. So with the help of bimetallic strip, whatever the temperature is, they expand to that extent, and then as a result they move that pointer to that one value. Okay, now look to the thermocouple thermometer. So in thermocouple thermometer, they are using electric current. Okay, and how they are doing it, let's look to it. Okay, there are two junction in the thermocouple at temperature. Let me change the color. One junction is here and the other junction is here. So the one junction is called hot junction and the other junction is called cold junction. Okay, and one these copper, the one wire is made up of copper, and this constant wire, it could be anything. In most of the cases it is made from iron. Okay, so what will happen if you, for example, if you put this hot junction in a hot water. Okay, for example, in hot water, so when you put that in hot water, so the temperature of the hot water is increases. So what will happen, the electron will start moving from this water in this wire. Okay, it will start toward this meter and then it will come to this cold water. As a result, this ice will become electronegative. The negative charge will increase here. Okay, the negative charge will increase here and positive charge will increase here. When it's reached to this ice, some of the current will start going back to the hot water, but the amount of current would be less as compared to the copper wire which is traveling in the copper wire. If you look to this, it is making a complete circuit. So when there is a high temperature, there would be high current flowing through these wire, and this meter will tell you if the temperature is high, there would be high current. Okay, and if the temperature is low, it will show you low temperature, or what may ever that hot junction detect. Okay, whatever that temperature is, it will show you in the form of current, that at this current it is equal to this temperature, and at this current it is equal to this temperature. Okay, in modern days thermocouple are now in this shape. Okay, there are one hot junction and there are one cold junction, and the basic principle is followed also in this machine. Okay, now next let's go to the other example, what the other thermometer are using, the other property. Okay, liquid. Now look to the book, we have a liquid crystal thermometer. So what happened in liquid crystal thermometer? It says that in a liquid crystal thermometer, the liquid crystal change to their different but distinctive color at different temperature. Then another temperature is resistant thermometer. In a resistant thermometer, the resistance of the wire changes uniformly with changes in temperature. In liquid crystal, they are using liquid crystal. That will tell you, this liquid crystal will tell you the temperature. And the other thermometer, it is the resistant of the current, okay, in the wire. It will tell you the temperature. Let's look to it. Now the first one, if you look to this, it is liquid crystal thermometer. In this strip, the color you are seeing, in this colorful portion, there are liquid crystal, and this liquid crystal are temperature sensitive, okay, and each crystal liquid show you different color at different temperature. For example, in 96 or in 36 degrees Celsius, it will give you the temperature like this, blue, okay, near to violet blue. And in 37 degrees Celsius, it will show you the temperature that would be it will show you the color that is almost near to green, okay. And in 38, it will show you the color like brown. Now what the basic principle it is here, these crystal on liquid form, so when you give them a temperature, it expand. When it expand, it gives you color, okay. So if you put that strip on the forehead of someone, and the temperature of that person is 36, so it will show you the color of green, okay. It will show you this color, okay. If 37, then they will show you brown color, okay. So just by changing in temperature, the liquid crystal, there are different type of liquid crystal, they show you their own distinctive color, okay. Now look to the resistant thermometer. So this is the resistant thermometer. In resistant thermometer, what will happen, there is the main important thing in this is this, the coil, okay. The coil detect the temperature, okay, and there is a power supply, the current, okay. There may be a battery, okay. So the current is going in this wire, okay, and it is also then coming toward this coil, okay. These wires are wrapped around from this coil, okay. The wire are wrapped around just like, and then they are attached, and the current is coming back. So a complete circuit is over there. So what this coil is doing, if you put this coil in a hot water, okay, so the temperature affect the current, okay. It affect the flow of current, the current which is going in this wire, it will affect it. That affection, or that difficulty to that to the path of current is called resistance, okay. And it will tell you that the resistance is high or low in this meter, and that resistance is made by temperature. So if the temperature is high, there would be high resistance. If the temperature is low, there would be low resistance. So then this, according to this meter, you will know that at this resistance the temperature is this, okay. So in resistant thermometer, they are using the resistance to electric current to tell you the temperature, because at different temperature there would be a different resistance, and that's how the ammeter will tell you the different value of the resistance. In 100 degrees Celsius there would be more resistance as compared to 70 degree Celsius. I hope you will have understand this lecture. Okay, and my homework for this um, topic is that you should know more about the physical property, how physical properties are used for thermometer. Okay, we have just example, the physical property that are used in thermometer. First it was in liquid, and in liquid they were using mercury or alcohol. Okay, in the second there was a bimetallic strip. Okay, and there is in the bimetallic strip they were the uneven expansion of those two material they were using to indicate a temperature. Then they were also using a constant gas thermometer where there was a closed flask, and just in the expansion and contraction in those air molecule they are telling you temperature. Let me remind you of one thing more. The pressure cooker what you are using in the kitchen, they are working on the same principle as the constant volume gas thermometer, because you just when you close the lid on that cooker, the air inside them is trapped. Okay, so once you hide the heat, so the pressure is also becoming high. Okay, then we have also studied the liquid crystal, so they were using the crystal for their temperature. Okay, so I hope you will have understand this, and you should need to read about more how much other thermometer there are and what physical property they are using. Okay, thank you. Allah Hafiz.